So we're going to look at a Java program from the textbook. This is listing 2.7, but we're going to build it up in pieces. So I'm going to come into my project for Chapter 2, and I'm going to go to New and Class. And the class name we're going to use here is Show Current Time. Now, time is an interesting concept. In computers, it's very important for networking that time elements are passed appropriately. You can sometimes see this. Remember always to have the public static void main here, sorry. If you ever have your system clock wrong, when you go to do updates, it can sometimes give you errors. And time stamping and time validation is an important part of computers. And so what we're going to do is we're going to look at what the system clock has. We're going to pull information from the system clock. Now, computers start counting time from midnight, January 1st, 1970, at Greenwich. I think it's Greenwich. And this is called GMT, Greenwich Mean Time. So all of the information we're going to get from the computer will calculate the time from January 1st, 1970 currently. So when we're building this, our input section, which will be here, will want to get the time from the computer. So if we're looking at an IPO, input, processing, and output, our input section is going to get the current time from the computer. So we're going to have long, because this is a very large integer number created by the system clock. And we're going to have the total, the system time. I guess your textbook uses total milliseconds. So I'll stay with the textbook, though I find that naming a little odd because I would call this the system time. And so what we're going to do is we're going to use a Java library, a built-in function called current time millis. And so we're not just going to type this code in, we're going to look at what each of the sections do and explain each section out. So I have now just gotten the system time. So what I'm going to do is, with no processing for it, I'm just going to display a print line, and I'm just going to put what the total milliseconds are currently from the system time. So if we run this, we see that this is how many milliseconds it's been since midnight, January 1st, 1970 in Greenwich, England. Now what we want to do is we want to make this human readable. So we have to do some conversions on this number. So the first thing we're going to do is we're going to convert milliseconds to seconds. And so I'm just going to leave a comment for everything I do here. Again, these are large numbers. So I'm going to do a long, and it's going to be the total number of seconds. And if we think about milliseconds to seconds, milli is 1,000. There's 1,000 milliseconds in a second. So this thing is 1,000 times bigger. So we're going to want to divide it by 1,000. Now this will truncate off any milliseconds left over, so we won't see 3.5 seconds. We'll go to straight seconds. And I'm just going to continue doing print outs here so that we see each of our outputs. We'll see what we've put into memory, and I guess to label it, I'll say seconds since 1/1/1970. Right, we want our display to have some meaning towards us. again, we're going to modify this display throughout this. And so I have these two outputs now. And if we run this, let's put a space. Get a better display. Now notice the way I'm programming, because this is an important when you're first starting to do a program, and you have an idea of what you want to do. As you do certain parts of it, you want to double check to see if they're working. And notice the milliseconds. If we take three digits over, we've lost this 879 milliseconds, but we do have the number of seconds. Now, our goal here is to get a human-readable clock, some clock where we can display something that looks like a digital clock. We want hours, minutes, and seconds. And so we need, so find the display value for seconds. And if we think about a second, seconds there's 60 seconds in a minute. And so as your clock hand goes around, it will only go from 0 to 59. Once it scrolls from 59, it increases the minutes. So these total number of seconds since midnight in January 1st, 1970 Greenwich Mean Time is working its way around a clock, and we're only going to want numbers between 0 and 59. And the way we can get that is to, and your book uses current seconds for this. I prefer display seconds, but again, we'll keep the same values as your book, roughly. So if my clock can only display 0 through 59, if I do a modulus of 60, the remainder is what I want to display on the clock. We can think about it, this clock is ticking forward, it's going 1 second, 2 seconds, gets to 59 seconds, and it flips over a minute, and it's back to 0 seconds. And so we kind of want to know how many times has it done this since January 1st, 1970, and we want the remainder, because the remainder is what will be displayed on the clock. So I'll come down below, and what we'll do is we'll make sure that we're displaying the seconds properly. Again, I'm labeling this so I can see what my output is, because we're slowly stacking some output on the bottom. But what I'm doing is I'm doing my calculations, and I'm double checking that the calculations work. And so if we run it, I keep remembering to put spaces between things. And so right now it's 48 seconds on the clock. If I hit it again, time has passed, and we notice that the clock face comes over. So I got to 59, so this should scroll over to the next value. And so we have a clock that's scrolling properly. And so we've got one component of our clock. We've got the second with the current second. And so now what we need to do is, well, how many minutes has there been since January 1st, 1970 at midnight? So what we want to do is find the number of minutes since, we'll just say 1970. And so my count of seconds has encoded in it how many minutes there were. Because if I take how many minutes, well, that's going to be my total number of seconds divided by 60. Again, this is integer division, so I'm going to lose any remainder, but we caught the remainder here for our display. And again, I'm just going to keep printing out all the information I'm learning about the current time. And so total minutes are the minutes since January 1st, 1970. So again, I'm using the display to show me what's happening in memory, and I'm checking to see if my code seems to be functioning like I need it to. And so where are we at? We're at about 28 million minutes since January 1st, 1970. We're going to do a similar process. So if we think of the minute hand on the clock, it goes from 1 to the 60th minute cycles back to 0. So it works very similarly to the second hand. So find the display value for minutes. I'm going to want current minute. So I'm going to want to do the same thing. I'm going to want to take the division of how many minutes there have been, and I want to get the remainder visible for the clock. So I get the 0, 1, 2, 3, 4, all the way up to 59. So I'll take my total minutes and I'll do remainder division or modulo division. And this is the first thing we can visually check now. So system.out.println current minute, and that's minute value for my clock. This is not a pretty display, but I'm at least seeing what's happening here. So again, I have my input, and I guess I'm going to call all this stuff here my processing. And down here, I'm doing a temporary display so that I know things are working for me. So again, if we're using our IPO method and I'm playing with my code and making sure each bit works, I'm leaving myself some comments, because 3 weeks from now when I go back to look at this, I'm going to wonder why I was particularly doing a remainder division versus an integer division. And so if I run this, 48 is the value, the minute value of the clock. And if I look down on my clock right now, it's 10:48 p.m. So this value is correct. So now we just need to find the hours for my clock. And so what I want to know is how many hours there have been since, find the number of hours since January 1st, 1970 at midnight. And a similar process is going to happen. I'm going to take my total hours, and that's my total minutes divided by 60, because that's how many minutes are in an hour. So I'm slowly building these values, counting how many minutes, how many milliseconds I've had since January 1st. I use my integer division to figure out how many seconds I've had since January 1st. I use my integer division to find out how many minutes I've had since January 1st. And I use my integer division to find out how many hours since January 1st. Again, I'm going to print this. And that is hours since January 1st, 1970. Now, a lot of this code I'm going to change once I'm sure it's working, but there's been about, not quite, 500,000 hours since January 1st, 1970. And so the last thing I need to do is find the display value for the hours. And right now we're going to do it in military time. So midnight's 0 and it ends at 11. So we're keeping everything long, so we'll do current hour. And now, when do the hours scroll over? Well, hours don't count by 60 like the minutes and seconds did. They count by, take my total hours, well, there's 24 hours in a day. And so the remainder will give me a military time. And here's where we'll probably see our first problem. Let's see, that is hour value for the clock. And so if I run that, I show that it's saying it's 2 o'clock, but my clock's saying 10 p.m. But if I have to remember, this was done at Greenwich Mean Time. So the system clock and computer times are all set from Greenwich, England. And to fix this, we would have to use time zones to move back and forth. And that's going to be an programming exercise that I'll ask you to do around Module 3 or Module 4, because you'll be able to adjust for time zones. And right now, this works. I have a clock here. And so I have all my values coming out into my display, but I want to display this better. So what I'm going to do here is I'm going to start with the print line, and then I'm going to introduce a new command from Chapter 4, which is a formatted print. But since we have all our pieces here, we're going to turn those pieces into a clock. So I'm going to get rid of these things I was doing to test my code. And I'm going to go system.out.println, and then I'm going to get the current hour. And then I'm going to put a semicolon or a colon, because I'm going to print to the screen a colon because we like to show things on the screen, right? If you think of a digital clock, you'll have the hour, colon, the minutes, colon, the seconds. So let's current minute. And then the current second. And because this is going to scroll over on the screen, what I'll do is after this plus sign here, I will let Java do a new line, and I'll tab in, because what's happening is the parentheses are holding what's going in here. So I'm going to space it across 2 lines, just to make it more readable on the screen. And so if I run this, if I haven't made any major errors, I get 253.33. Well, let's watch the second hand here for a bit. We'll come up, we'll get 41. Try it again, 47. What I want to see is what happens when it scrolls over. 53 and 56, so about 4 or 5 seconds. I'll give it a beat. And notice 0, I lose my placement. It moves over. The same thing's going to happen with the minutes. In about 7 minutes, this will be 2, 1, 0, and that doesn't quite display right in the clock. And so there was a set of commands and libraries. They're usually called C format statements, but almost every programming language uses them. So I'm going to use a command that lets me do format statements. So I'm going to come down here and I'm going to do printf. Now, what this will want is a string that has placeholders in it. And in our textbook, on page, let me get the right page, it's section 4.6. So that's on page 146. There's an idea of using these format codes. And what I can say is I can do %d, and that's going to hold the place for an integer. And then I'm going to put the colon that I want displayed on the screen. and then %d again. So I have a placeholder for my hour, colon, a placeholder for my minute, colon, and a placeholder for my seconds. But I need to tell printf what to fill into these placeholders. So this %d is holding a space in the screen for a variable. And so after that string, I need to tell it what to take. So, and it's in the order that they appear. So current hour, current minute, current second. And again, because this is scrolling off the screen, I'm going to break it on the comma here so it fits on the screen. So current hour, Java is going to put into the placeholder for D. Current minute, Java is going to put into the placeholder for D. And current second, Java is going to put in the placeholder for this D. And so each of these special characters are putting in the string a place for an integer. And then I have to tell it where in memory to get the values for each of these little placeholders. The colons are still going to be printed to the screen. So the only thing that tells the placeholder is the %d. The colon gets presented to the screen. Current minute falls into the second one. Colon gets printed to the screen. And so this is a way we can mix our variables with text without having to use the plus sign. And we're going to have some special formatting commands. And I still have both prints here, so I'm going to run them together. And so notice that we're getting the same output. And if I scroll over, I still have the same problem. But I can force the width of each of these. So if I put a number before the %d, I can force it to be 2 digits wide. So the 2d would be 2 digits. Now if I run my clock again, I have a place for 2 digits on my hour, I have a place for 2 digits on my minute, and I have a place for 2 digits on my second. So notice how it moved over because it's always going to have a consistent place. So every time I run this, numbers will fall in the same place. And so what I want to see is what happens when I scroll over. So we'll give it a few seconds here. 5 more seconds. What do they say? The waiting is the hardest part. So notice it left 2 places for it, but we really don't read clocks like this. And since these are integers, what I really want is I want the leading zeros. So I can tell it to do 0 to D. And what this tells me is if there's a leading 0, to leave it in place. And so now this little command here says current hour, put a 0 in front of it, and it falls into this place. And so current hour falls into this placeholder. It says it needs to be 2 digits wide and have any leading zeros. And I do the same thing for the minute. So we can really start placing things on our screen very specifically. And now if I run it, it's 025858, 025903, and now we have a digital clock that's giving us what's a military time for Greenwich, England. So I'm going to remove my test, and I now have a good formatted output. And in about 40 seconds, we'll watch it scroll over to 3. So waiting 40 seconds might be odd. Printf is very useful. If you've been working on your gratuity program, you'll notice that you'll get a lot of extra decimal places. And if I use an F instead of a D, I can manipulate floating points, and I can control how many decimal places it's going to display. And so printf is something we're going to want to explore for our output. We got 11 seconds to go, and we're going to see if this scrolls over like a nice digital clock. 1 second. I was close. And there we go. It's scrolled over. It's 3 o'clock. It's 0300, so it's 3 a.m. And 2 seconds passed when I ran the clock. Now, we're going to use parts of this. You have a program later where when we have the ability to print strings to the screen, you can be able to convert this to show AM and PM instead of doing a military clock. So, right, if I waited until 11 at night Greenwich Mean Time, it would show it as 23:00:02. And if you divide that 23 by 12, if it's a 1, it's PM. And if it's a 0, it would be AM. But we're going to need to have some statements, extra code to actually print the AM, PM. But that's something that we can do. Also, a program that I assign when we can start making decisions is to have this take into account time zones. And so we have a nice use for our integer division and our modulus division, and we've introduced how to format to the screen. I strongly recommend start playing with printf. Try to see if you can clean up some of your decimal displays, as that will help organize things on the screen. And the other thing we'll use here is there is a nanosecond command that gets the nanoseconds since January 1st, 1970, since modern computers have gigahertz processors. Nanoseconds are actually counted, while older computers with megahertz processors only had milliseconds because of how the clock speeds were internally on the computer. And we're going to be able to capture what the time is when we start, and then capture what the time is when we end a program. So we're going to be able to figure out how costly in time some of the things we do are. So play with this program in the book. What I wanted to show here is how we can think about how we code, how we can display what we're coding as we are working on it so we can correct errors quickly, and also different ways that we can start thinking about displaying things.